Okay, so now I will explain about what is thread cutting operation and how to perform thread cutting operation by using CNC turning center. So before explaining thread cutting operation, let us see what will be the cycle. So what is the cycle used for thread cutting operation? See, for thread cutting operation, we have to use G75 cycle. The G75 cycle means it's the external thread cutting operation. So now we will see. Sorry, G76 cycle. G76 means it's the external thread cutting operations or external thread cutting cycle. And this cycle so G76, so it is G76, nothing but thread cutting cycle. Now, thread cutting, thread cutting cycle is also known as G76 cycle. Now, what will be the syntax for G76 cycle? A G76 cycle, it consists of G76 and P, and this P consists of 6 number of digits. So we need to enter 6 digits. So this is a 1, 3rd, 4th, 5th, and 6th. I'll explain those digits. Then you have a Q value we need to enter, and we need to enter the R value. We need to enter R value in the first block. Again, in the second block, if you go to G76, so in the second block, we need to enter what is X value, then we need to enter what is our Z value, and you need to enter Q value, and the last one is we need to enter what will be the feed rate. Okay, what will be the feed rate of G76 cycle. So now, so in the first block, so I'll go to the first block. First block means G76, what is P value, what is Q, and what is R. So I'll take in first block, the first block P. So what is P indicate? So P consists of 6 digits. So I told the P consists of 6 digits. First 2 digits, first and second digits indicates first and second. And second digits indicates first and second. First and second digits. It's number of passes, number of finishing passes for thread cutting operation. So it is number of finishing passes. Finishing passes for thread cutting, for thread cutting, that is the P. And similarly, you have third and fourth digits. Third and fourth digits indicates chamfer angle of the thread. What is chamfer angle? The chamfer angle in terms of degrees. Then fifth and sixth digits. Fifth and sixth digits indicates, and 6 digits indicate it is thread angle. Is a thread angle. Okay. So this is P with respect to first block. See, these are all assumptions. First and second digits indicates number of finishing passes for the thread cutting. Let us assume number of finishing passes are 02 or 03 or 04 or 05 are the number of finishing passes. Third and fourth digits indicates chamfer angle. So chamfer angle we need to specify. So what will be the chamfer angle for the thread? So it may be a 10 degree or 5 degree or 15 degree or 20 degree, or even you can include 0 degree. I will not consider a chamfer angle to make this thread. Next you have fifth and sixth digits indicates thread angle. So thread angle in this problem, in some of the problem you will mention the thread angle. So in this problem thread angle is not mentioned. You need to assume the thread angle. So then I'll go to the next block. This is the first block, p value, and I'll go to the second. In the second will be the q. Second one will be the q, and this q indicates minimum. Q indicates minimum depth of cut in terms of microns. So it is a minimum. It is minimum depth of cut. Minimum depth of cut microns. Minimum depth of cut it should be in terms of microns. Okay, you need to keep q in terms of microns. So then you have r value. You have a r value. Say r is say r nothing but is the finishing allowances in terms of mm. Finishing allowances. Finishing allowances in mm. Okay, so this is first block. Then if you go to the second block of the syntax, the second block, you have 1 minute. Sorry. Okay, next step is we need to, in the second block, so we need to enter what is the value of x, what is the value of z, and remaining values. So now I'll go to x value. So x nothing but x will be the minor diameter of the thread. So we need to calculate what will be the minor diameter of the thread. So x nothing but is this minor diameter or core diameter? It is core diameter in terms of mm, and next one is I'll go to the z. So before go to the z value, we need to calculate what will be the core diameter, and this core diameter can be calculated by using this formula. So x is equal to, you have a major diameter. You have major diameter minus 2 into pitch. So it is major diameter minus 2 into thread pitch. So use this formula to calculate x value. So then next you have z value. Z value means it is a thread length from the reference. So it is a thread length. thread length in terms of mm. And next you have p value. So p nothing but, so in the second block, p nothing but height of thread height. The thread height of microns, terms of microns, and this thread height can be calculated by using this formula. So thread height p is equal to, you have pitch, thread pitch into thread pitch, then into, you have 0.61343. So this is the formula. We need to calculate this value, and we are getting in terms of mm. So convert it into microns by multiplying 1000. So that is thread pitch. So then after completion of thread pitch, so the next one is you have Q. Q is maximum depth of cut in terms of microns. So it is maximum depth of cut. Madam, ಹೇಳಿ madam. ಇನ್ನ ಬಂದಿಲ್ಲ ಮೇಡಮ್ ಡಿಪ್ಲೊಮಾ ಅವರು. ಮೇಡಮ್ ಅದು ನಿಮಗೆ ವಾಟ್ಸಪ್ ಮಾಡೋಣ ಮೇಡಮ್. ವಾಟ್ಸಪ್ ಮಾಡ್ತೀನಿ ಮೇಡಮ್. So here it is maximum depth of cut in terms of micron. Maximum depth of cut in microns. So that is Q value, and last one is F nothing but it's a feed rate. So F nothing but it is not feed rate. 1 minute, I will cross check. F is thread pitch. It is not feed rate. Sorry, F is thread pitch. F is equal to is a thread pitch. F is thread pitch in terms of mm. Okay. So you need to consider these parameters. You need to consider this calculation part to write the program in thread cutting operations. Okay. So now we will see the problem. How many students were there? Okay. Okay, you can put 2 into F. Which one? Which formula? P, the die. X value, major diameter minus 2 into P, 2 into F. Yeah, that's fine. Just for your understanding purpose, I put 2 into thread pitch. Okay. So this is the calculation part we need to consider to solve the problem. So now I'll go to the problem. So before writing any part program, you need to consider the blank or billet. You need to consider the billet. Say this is a billet. This is a billet, or anything what is a raw material. It's a billet of dimension. We need to assume the dimension. What are the dimensions of this billet? Let us take x will be the, I am assuming x is equal to x nothing but diameter. Say is 105 is given. Let us take 110 mm will be the diameter of the billet. Then similarly I will go to the length of the billet. So I will go to the length. So length nothing but it's a z dimension. So z is 150 is given. Let us take 160 mm will be the length of the billet. Okay, so we need to consider these dimensions. So now I will construct one axis. I'll construct one axis line. See from here. I'll construct one axis line. Let us take this is okay. So this is the axis line. So now we need to measure some of the dimensions. Say, assume this one I'll call it as this point, this intersection point. I will call it as 1, and this one I'll call it as 2, and this one I'll call it as 3. So this one I'll call it as 3, and this one I'll call it as 4. This one I'll call it as 5, and this one I'll call it as 6. This one I'll call it as 7. Okay. So these are the we need to calculate these coordinates. So now I'll go to coordinate number 1. So for 1, the coordinates are 0, 0, 0, 0 will be the first coordinates. Then we'll go to the second point, second coordinates. You have x and z value. So x is diameter is 40, and z is 0. That is for second. And for third, it is x is 40 mm, and z is minus 35. Z will be the minus 35. And if you go to the fourth one, diameter. So diameter is a M70 into 1.5 is given. M70 is measured eye is 70, and the pitch is 1.5. So here diameter is 70. Diameter is 70 at point number 4, and x is minus 35. So next I'll go to point number 5. I'll go to point number 5, coordinate number 5. Coordinate number 5, the major diameter is 70. The distance is 77 plus 35. How much? 77 plus 35? 110. 112. 120. 112. Check in the calculator. 77 plus 35. 112. 112. Okay. This is at point number 5. Next, I will go to point number 6. I go to point number 6 or coordinate number 3. At coordinate number 6, the x will be the diameter is 105, and z is 112 plus 15. How much? 112 plus 15. 127. 127. And I'll go to point number 7. So at point number 7, the diameter is 105, and the distance is 150. As from the diagram, we are getting 150. Okay. So these are the coordinates we need to calculate. So after calculating the coordinates, the next step is you need to write the program. Point number? What is the minus 35? At point, okay, 35 I'll consider. So it is minus 35 I'll consider. Okay. While writing the program, I'll consider minus 35. So this is the coordinates. Okay. And remember the calculation part along with the coordinates. So now next step is we need to draw. Sorry, we need to write the program for this profile. Okay, so wait another 3 minutes. I'll come back. Okay, just 3 minutes. Just go with the calculation part. If you have any doubts, you can ask me. So I'll come another 3 minutes. 3 minutes. Okay, the next step is we need to write the program. So we need to write the program in the next step. So now before writing any part program, we need to specify the program number. So program number I'll call it as A1, 2, 3, 4. This will be the program number. Then next we need to specify the block number N01. So here we have to write the program for rough turning, then grooving and thread cutting operation. So these three operations we need to perform. So first let us consider rough turning operation, then we will see grooving and thread cutting operation. Now I return block number N01, block number 1, and dimensions are given in terms of metric. I will use G21, and feed rate I am assuming in terms of mm per minute. I will use G98, feed rate in terms of mm per minute. So now I'll go to the next block N02. So I'll reset that tool. I'll assign the tool to its own portions. So because previous programmer, I don't know where is the tool as per the previous program in a turning center. So I'll reset that tool by using G28, U0 and W0, where U and W are secondary moment of tool with respect to X and Z directions respectively. So now I'll go to the next block N03. So before performing any operations, we need to switch on the coolant. So coolant on is M08, spindle on in clockwise M03, and specify spindle speed. Let us take spindle speed is 1800 RPM. That will be the spindle speed. Next we go to the next block N04. The next one is select the tool to perform some specific operation M06, and tool number I am using T01 will be the tool number. So next I'll go to the next block N05. So identify the start point of cutting tool. So identify the start point of the cutting tool to perform rough turning operations. The start point of the cutting tool is look at the cursor, the movement of the cursor. So this will be the start point of the cutting tool. So before performing rough turning operation, we need to bring the tool to this location and start writing the program. So now rapid movement. So I move the tool rapidly from tool turret to this reference point. So coordinates at this reference point is look at the billet dimension. X is 110 and Z is 160. Therefore, the coordinates at this point is 110 and 0. So here it's a linear rapid interpolation G00, X is 110 and Z becomes 0. So this is the initial position of the tool to perform G71 cycle. So now I will use G71 cycle. So G71 cycle is a rough turning cycle. So G71, U is finishing, U is minimum depth of cut. I am giving minimum depth of cut is 0.5 and R is retract. I am assuming retract is 1 mm. Next N07, so I'll use G71, P is starting block number is 08. After N07 you need to write 0 N08, so therefore P is 08. Q is end block number of this cycle. I don't know where is end block number. I will write it later. So then after that we need to enter finishing allowance in X direction, that is U. I am assuming finishing allowance is 0.01. This is assumption. And similarly finishing allowance in Z direction, that is W. You need to assume W value. So W also I'll assume 0.01. These are the assumption U, W, and you have feed rate. Feed rate I'm assuming, let us take feed rate is 55 mm per minute will be the feed rate. Okay. And I will enter Q value later. So now I'll go to the next block N08. I'll go to the next block N08. So here as per this set of instruction, tool is somewhere here. So now look at the part sketch. The tool is somewhere here. So I move the tool from here to point number 2 or coordinate number 2. So that is while moving we have to remove some material. So that is G01. The coordinates at point number 2. So X is 40 and Z is 0. Coordinate at point number 2. Next I'll go to the next block N09. So now I'll move the tool from 2 to 3. So 2 to 3 movement is a linear interpolation. 2 to 3 is linear interpolation. So therefore I will use G01 and coordinates at point number 3 is 40 and 35. So X is 40 and Z is minus 35. Next I'll go to the next block N10. I'll go to the N10. So now tool is at point number 3. So I'll move the tool from 3 to 4. The coordinates at point number 4 is 70 and minus 34 and it is linear interpolation. So we have to use G01. So I already mentioned G01 in block number 8 or in previous block I used G01. So here no need to repeat G01 code. So now I'll enter the coordinates only at point number 4. So that is X is 70 and Z is minus 34. Next I'll go to the next block N11. Now tool is at 4. So don't consider threads now. Don't consider thread cutting. This is 35. This is 35. Don't make it 30. Make 34. It is 35. So next I'll go to the. Now I'll move the tool from 4 to 5. So 4 to 5 is linear interpolation. Enter X and Z. X is 70 and Z is minus 112. So this is N11. So next I'll go to the N12. Now tool is at point number 5. So between 5 and 6 you need to perform grooving operation. So while writing the program for G71 cycle, so neglect the groove and write the program. See, simply I will move the tool from 5 to that corner, vertical corner. Then I will move the tool vertical upward. So here I have not mentioned the coordinates. After 5 I mentioned the 6. So what about the coordinates at the corner? Just extend point 5. It will intersect the vertical line. So find the coordinates at the intersection point. So it is again it's a linear interpolation. The coordinates are 70 and Z become 112 plus 15. So how much are writing? 128. Is it 128? 112 plus 15. 127. This is minus 127. So that is a Z value. So next I go to the N13. I'll go to N13. So now move the tool vertically upward. See at point number 6. So again it is a linear interpolation. X is 105 and Z is minus 127 will be the Z value. So next I'll go to N14. I'll go to N14. So now I'll move the tool from 6 to 7. So again into a linear interpolation. Enter the enter X is 105 and Z is minus 150. Okay. So now I completed the profile. Now the Q value is 14. Now the Q value is 14. Okay. So now the next step is send this tool to its home position and call new tool to perform grooving operation. So now I am sending this tool to its home position. Use G78, U0 and W0. I am sending this tool to its home position. Now I will call new tool. N16 I am calling new tool. So that is M06 will be the new tool and enter tool number. Say assume tool number is 02. 02 will be the grooving tool. So next one is, see last class I explained about the grooving operation, how to make grooving operation. So before using grooving cycle, you need to specify what will be the start point of the groove. What will be the start point of the groove? So in this case, we need to make the groove between 0.5 and 0.6, or coordinate number 5 to 6. We have to make a groove. So now my start point for the groove is coordinate number 5. So now there I will move the tool rapidly at point number 5 or at coordinate number 5. So it's a rapid movement. So I'll use G00. And coordinates at point number 5 is X is 70 and Z is minus 112. So this is the coordinates at point number 5. This is the start point of the groove. So next I'll use the syntax N18. I'll use the syntax. For grooving we have to use G74. I think it is G74. You have to use G74 for grooving cycle. Okay. So now for grooving is G75 and thread cutting is G76. So it is G75 will be the grooving cycle. So now I'll use retract. I will follow the syntax retract of grooving. So it is R1. See, after making groove, so the tool has to retract 1 mm above. So next I'll go to N19. Go to the next block N19. So again it is G75, X and Z. X nothing but what is the diameter of the groove. So what is the diameter of the groove? Look at this sketch. The diameter is 45 is given. So diameter of the groove I will specify X is 45 and Z means what will be the length of the groove from the reference. See, the length of the groove length is 15 mm, but we need to measure from the reference. From the reference means from 0, 0 or from the coordinate number 1 we need to measure. So that is 15 plus 77 plus 835. So it is we have 15 plus 77 and 35. So the length of the groove is 127 minus 127 will be the length of groove from the reference. Okay. So this is XZ and the next term is you have you need to enter what is P and what is Q. P is step pecking incremental distance along x-axis. I am assuming 250 mm and Q will be the stepping incremental distance along z-axis. These also I will assume 250. These are the assumptions. Okay. And the last one is you need to enter what will be the feed rate. So feed rate I am assuming some 45 mm per minute will be the feed rate I am using for a grooving cycle, that is G75 cycle. So next, so this completes the grooving operation. So next I will go to you have one more operation called thread cutting operation. To perform this thread cutting operation, we need to send the grooving tool to its home position and call new tool to perform thread cutting operation. So now I will send this tool to its home position. So now you use G28, you have U0 and W0. I am sending this tool to its home position. Now I am calling new tool. I am calling new tool, that is N21. N21 and new tool. So tool chain or call new tool M06 and tool number I'll use T03. So T03 is the new tool I'm using for thread cutting operations. So next I'll go to next block N22. So before performing thread cutting operation, we need to specify which is the start point of thread cutting operation. See, look at the diagram. So in the diagram between 4 to 5, we need to make external threads, and is given some dimensions. That is, major diameter is given 70 mm and pitch is given 1.5. So these parameters are given. Major dia is 70 and pitch is 1.5 is given. So now I will write major diameter. I will write. I will use the syntax. So this syntax says that. So before writing the syntax, you need to call the tool, threading tool, to the start point. Where is the start point? Start point of thread cutting operation is 4. So now I'll move the tool rapidly at point number 4. So it is a rapid movement. So G00. So what is X and Z at point number 4? So X is 70 mm. X is 70. X is 70 and Z is at point number 4. Z is minus 35. Z is minus 35. So this is a rapid movement of tool. So now I'll go to N23, next block, N23. Now use grooving cycle, use thread cutting cycle, not grooving. I'm using G76 cycle. So follow as per the format. So it is G76, G76 and P. I told P should consist of 6 digits. First 2 digits indicate number of finishing passes for thread cutting operation. I am assuming 2 finishing passes or 3 finishing passes or 4 finishing passes. You can assume these finishing passes for the P value. So now I will assume 3 finishing passes, therefore P03, that is first 2 digits. Third and fourth digits indicate chamfer angle. Say I am assuming chamfer angle is 10 degree. Therefore I will write 10, that is third and fourth digit. Then fifth and sixth digits indicate thread angles. Let us assume the thread angle is some 40 degree. Thread angle is 40 degree. Therefore I will write 40. So P should consist of 6 digits. 03 indicates number of passes, 10 indicates chamfer angle and 40 indicates thread angle. So this is P value. So next Q is minimum depth of cut in terms of micron. Let us assume the minimum depth of cut is 250 microns. This is an assumption. So I will assume the minimum depth of cut is 250 microns. Okay. So that is a Q value. Next you have R is, so R limit finishing allowance in terms of mm. Let us assume I am assuming finishing allowance is 0.05 will be the finishing allowance in terms of mm. So this is finishing allowance. So next I'll go to the next block N0, N24, G26. See, in the next blocks we need to calculate what is X value. We need to calculate major diameter, and also we need to calculate what will be the thread pitch. So this calculation part is very important. I'll do the calculation part. So now I'll go to the first one is we need to calculate core diameter. We need to calculate core diameter. So X indicates core diameter. Core diameter. So this is very important. And you need to calculate these, you need to show this calculation for core diameter. So how do you calculate this core diameter? X nothing but is the core diameter. So now core diameter, it should be calculated by using the formula X is equal to major dia minus 2 into pitch, 2 times of pitch, 2 times of pitch or thread pitch. So again X is equal to, again I will write X is equal to major diameter M70 is given. 70 will be the major diameter minus 2 into the pitch value is given 1.5, which is mentioned in the problem. So now this becomes 70. The next part is we need to do this calculation part. How much reading? These are 2 into 1.5. What is 2 into 1.5 is 3. Then 70, 67. So x is 67. So we are getting x is equal to 67 mm. So this is x value. Then next one is, so after calculating x value, the next calculation part, I'll show the next calculation part here. So next calculation part is we need to calculate P, thread pitch. We need to calculate P. P nothing but it's a thread pitch. The thread pitch. So thread pitch is calculated by using this formula. So here it is a P is equal to P, P nothing but is a thread height, not thread pitch. It is a thread height. It is a thread height. Thread height. Therefore, thread height P is equal to pitch into pitch nothing but is a thread pitch. Pitch into as 0.61343. Therefore, P is equal to pitch is given 1.5 into 0.6143. So P is equal to how much rating? 82092. 145. You are getting in terms of mm. This is we are getting in terms of mm. But for our calculation purpose, we need to substitute thread pitch in terms of microns. So we need to specify the P should be in terms of microns. To convert into microns, so we need to multiply by 1000. We need to multiply by 1000. Therefore, P is equal to. If multiply with 1000, then it will become 920 microns. 921.145 microns. In terms of microns. In terms of microns, so we need to substitute the values in terms of microns. So this is a small calculation part in thread cutting operation. So now I'll go to the N14, N24. I'll go to the next block, N24. Then I'll use G76, X. We need to enter what is the X value. X nothing, what is the major diameter? So we're getting 67 mm. X is 67 mm, and Z is thread length from the reference. So thread length is 77. We need to enter Z value from the reference. 77 plus 35. 77 plus 35 is 77 plus 35. Is 112? So Z is minus 112. So that is Z value. Next, I'll go to P value. So P is thread pitch in terms of microns. Okay. So now in this case, thread pitch in terms of microns. So we got P is 0.92014 mm. If it is in terms of microns, 920.14. You need to substitute the 920.14. Okay. So that will be the thread pitch in terms of microns. So that is P value. So then Q is the maximum depth of cut in terms of microns. Q is maximum depth of cut in terms of microns. So minimum depth of cut I given 250. Therefore, maximum depth of cut should be greater than 250. Let us assume it is 300 microns. Okay. So then the last one. If you go to the last one, F is thread pitch. See, generally the students will make the mistake while writing the F value. Instead of thread pitch, they will specify, they will assume it as feed rate. So don't enter feed rate value, we need to enter thread pitch. So F, the thread pitch is given 1.5, therefore F is 1.5. F is 1.5 as per for this problem. Okay. So now I completed thread cutting. I completed thread cutting operation. The next step is assign this tool to its home portion. Now we don't have any other operation. I am sending this tool to its home portion G28, U0 and W0. I am sending this tool to its home position. Then I will switch off the spindle and coolant on. Spindle off is M05, coolant off M09. And in next block N27, end of the program with rewind. So that is M30. End of the program with a rewind. That is M30. Okay. So this is the complete program for the given profile. So in the given profile, we need to, it consists of rough turning. So rough turning, it may be a step turning or plain turning or taper turning, and grooving is also is there, and thread cutting operation is also there in the given profile. So this is a complete profile. Okay. So you need to execute this program. You need to execute this program. So now the time is 3:30. Will you execute this program? Software? Just type the program. Copy the same program. Lathe. L means lathe. For lathe, you have to use, for this operation, you use lathe. For M means milling. Use Funnel.
Excuse me, sir. Should we write this in the record, sir?
You need to write these details in the record. The calculation part, everything you need to include.
Okay, sir.
And today morning I shared one more screen. I think I posted in your WhatsApp group. With respect to thread cutting, you can include that problem. For the today's morning first batch, I conducted that one. And this is for the second batch. You can include these two programs in the record. And tomorrow, tell me.
Okay, sir.
And tomorrow I am conducting lab internals for batch 1 and batch 2 at 1:30 p.m. See, morning first 2 hours, just complete your assignment, complete lab record writing, everything. Then third and fourth hour, I think you have some, you have what we are calling, some events. Every Wednesday you are conducting, right? You are attending the event every Wednesday. So maybe tomorrow you have some online session, third and fourth hour, you can attend the online session, and afternoon 1:30 I will start the internals. So bring A4 size sheets. So you need, it should be online only. Okay. If you are interested to come to college, you can come. So it's better you can take online. I take 2 A4 size sheets, and I will post the, I'll give the same question for all students. One turning program and one milling program. I will post. I'll share these two images through your WhatsApp, so you can download those images and start writing the program. For one is turning and another one is milling. So after writing these two programs, you need to take the snapshot of the return program, and upload in your MS Team. Then I will conduct a quiz. I will share 10, I will conduct to conduct Viva question, I will conduct a quiz. I will share 10 questions, 10 or 15 questions, and I will give duration is 10 to 15 minutes. Maximum I give 10 minutes duration. Within the duration you need to complete the quiz. So that marks I will consider as Viva, similar Viva. Okay. So this is the procedure, and everyone should switch on the camera because I want to see whether you are where you are writing, whether you are seeing any other. See, I will not give the problems. What are the problems we solved in the class or in the lab? I will give some other images. See, this problem I will solve in the class. I am not giving this problem. I will give some other problem. So like that, I will arrange two problems and we will conduct. Okay. So and if you miss the internals, I will not reconduct. I will not take. I will not conduct once again. If you miss the internals, inform your friends. And even today evening, I will put the message regarding your internals. You can go through those message and attend the internals. Okay, and see your friend. Your one of your friend will share the. You will share the screen using the software. You will run the software. Okay, you will type this program, you will feed this program in the software, and it will show whether you are getting output or not. We need to verify. Okay, wait another 10 minutes, we will wind up. Finished? Okay. share your screen. No, yeah, it's okay. Now you open this one.
Yes,
Teams.
sir. This part, what is showing in 24?
What is it showing? Check enlarge. Invalid number, huh? Which one? G76 PQ, then go to next one. Right side you need to enter F value, right? You take 920, remove 0.14. Now you execute. Or don't specify Z0. Remove Z0. G00. Give the previous problem. Yes. This one, no?
No, sir. Like yesterday, what I did.
Do one thing here. Instead of Z0, you go to Z plus 1. Include Z plus 1 or X triple 1. A tool should not touch the X surface, Z1. Now do it. So you got to get it. See here, I will make it one thing. G01, X40, next line Z0. Put Z0 next line. Just enter. Enter. Okay, now you check. Put Z0. Don't enter any value. Just put Z0. Now you check. The blue itself we are going to work on.
Yes.
Put G01. Oh, we are not looking. Oh, on is correct. What is G21 U0?
Yes, sir.
Why you have written G21 U0? When U0 is not there. G21 G98. Now you try. Make it G00. This is G00. It's correct only. Or travel. So what is the billet size? You not mentioned billet size now. The program. In the program you need to specify the billet size, right? After A 1, 2, 3, 4, specify the billet. What is the billet? Here I am not specified a billet, you need to specify the billet. So X110 and Z is 160. X110 and Z is 160. Okay. Big that tool definition is not required. Let's remove that line. Remove that complete line. Now you run. Z0. It's required to start roughing. Sunset. This time it's 40. So put G00 here and here another G01. Put G00, G01. Okay, do one thing. Whenever you are free, maybe during third internals, you come and practice in the system. Okay, you save this program and try to practice in the system. So today I'll wind up this session and we'll see tomorrow. Tomorrow at 1:30 you have lab internals. Okay, or inform your friends to attend the lab internals. Is it clear? Okay, thank you. Why you are not in? Except record to start roughing.